Good afternoon. Welcome to the Raymond and Beverly Sackler Faculty of Exact Sciences Symposium, Exact Sciences Igniting Tomorrow's Innovation. We are honored to have with us distinguished guests, including Director of Tel Aviv University, Professor Mark Steif, the Dean of the Faculty, Professor Tova Milo, and our keynote speaker, Mr. Eyal Waldman, winner of the 2024 Israel Prize for Entrepreneurship. We are also delighted to welcome our esteemed faculty members, Board of Governors members, Tau alumni, friends, supporters, and students. Without further delay, let's begin by inviting Professor Mark Steif, Rector of Tel Aviv University, to the podium to open the symposium.
Thank you. Well, I should start by saying these are difficult times, so thank you for coming, especially those of you who came from out in Israel. These are very difficult times in Israel. And thank you for being here and standing with us. Especially thanks. Now, this, we're the hero of change. Change, rapid change. It changes everything in our lives. Social lives, our children change, our students change, everything changes. The way we teach should change. Everything is changing around us. But what is interesting and important is that this change is driven by changes in science, which drive changes in technology, which drive everything else. And everything starts from exact sciences, at least everything that has to do with the changes that we are now experiencing. This is the product of many years of progress in advanced sciences and technology, and this is indeed something that we should acknowledge for the better and worse. So the people here are both to thank for the revolution that we're experiencing and to blame for it at the same time. We have to decide which is more important. So I hope that this event will be, I'm sure that it will be successful, and I welcome everybody here, and let's hear what, let's start.
Thank you very much, Professor Steif. I would like to invite Professor Tova Milo, Dean of the Faculty. Lee.
Hi. Normally, in regular times, this would be a super happy, exciting event for all of us. Still exciting, happiness, difficult with that. These days, these are not easy times for the students to learn, for the professors to teach or to do research. But I think one of the strengths of our nation is that we keep going no matter what. And we're sad, we're grieving, but somehow we manage to maintain a semi-normal life in parallel to all the difficult things. And I think this is really important, not just for everyday life, but really for the future of the nation, because without all the students that we have here that will eventually graduate, without all the wonderful research that we are doing here, this nation we vanish in some sense. So I should thank everybody that is contributing to that. These are especially difficult times also because of the boycott, the academic boycott from abroad, so internal strength is really, really important, and external support from all our friends and supporters is very important. Before we continue, maybe I should tell you what is a dean, okay, and what's a faculty of exact sciences. Okay, so some of you are already, faculty here or friends and know, but I'm sure some kind of wonder. So the Faculty of Exact Sciences is composed of 5 schools, the School of Computer Science, the School of Mathematics, Chemistry, Physics, and Environmental Studies. And the dean is the one that is in charge or responsible for the good things and bad things that happen here. And I'm very lucky because this is one of the most amazing faculties in the university. And moreover, if you pick a buzzword, any buzzword in technology today could be quantum computing or quantum in general, cyber, AI, advanced chemistry, environment, everything is done here. All the fundamentals, the really important research is done here. But sometimes it's a bit frustrating when I go to listen to some talks in the west part of the campus. You go to a lecture in history, you go to a lecture in social sciences, you see there, you kind of understand. Okay, you understand the words, maybe not the depth of the results, maybe not exactly how it relates to other things, but you understand. You go out of the lecture feeling that you understood something. In exact sciences, it's far more frustrating, and even me as a dean, if I go to listen to a talk in physics or chemistry, or even computer science, which is my own discipline, often I don't understand a word, because the way science is built here, it's by pillars over pillars over pillars over pillars, and you don't even understand the terminology. So one of the goals is today is to tell you all how wonderful we are, how important we are, how much you should support us, contribute, collaborate with us, donate, everything, because we're amazing. And in order to do that, we try to make science accessible. And we will have talks from each one of the schools here highlighting one amazing things that we're doing. And we'll try to make it in a way that even I will understand. Okay, so that's our goal today. And before we start, the most important things are to thank whoever deserves. Huge thank you for creating this event. So now I'm going to read because this is really important, okay, not to miss anyone. So first, I want to thank Director Mark Stein for coming. Eyal Waldman for participating here. I would like to thank really the researchers that we present here later on. And special thanks to Sigalit Ben Chayun from the CEO of Tau Alumni Organization and her team. And really thank you from all our hearts for helping to create this thing. And thank you, Adi Omer, the CEO of Israeli Friends Organization, and all the other Friends organizations that are coming and supporting us. Of course, thank you to all the people that support, everybody that came. And I hope we'll have great fun today. And to start, I would like to invite Eyal Waldman, the winner. But yes, up. We are really, really proud and very happy that you agreed to come. Eyal is the winner of the 2024 Israeli Prize for Entrepreneurship. He's the chairman of Waldo Holding and the founder and former CEO of Mellanox. Thank you for coming, really. And I would like to also invite Professor Michal Feldman from the Blavatnik School of Computer Science. She's amazing. Okay, she specializes in computation and economics, and I'm sure you'll enjoy the interview that you will hear. Thank you.
Okay, hi everyone. Thank you for coming. Eyal, it's a great honor and pleasure to have you here. We have many questions. We want to hear from you everything, and we have just 20 minutes, I believe. So I'd like to propose a deal. I'll keep my questions brief, and you'll do the same with your responses.
I just want to tell everybody there's a great beach, and enjoy Tel Aviv while you're here. It's anybody that came from abroad, and try to use as much as you can the time in Tel Aviv. It's an amazing city.
So, as Tova said, you just won the Israel Prize for Entrepreneurship. And the first question is whether you can share with us a moment of excitement throughout this very long process.
You mean before everything?
During, after?
I think it's a great honor to be acknowledged as the entrepreneur of the year and get the Israel Prize. There was a process with people that were not involved until I was able to get the prize. But it's a great honor. I think there's thousands of people that have worked with me, both at Galileo Technology and at Mellanox Technologies, two companies I was one of the founders, that deserve the recognition, and I'm proud to represent them. And I think what's important about this country is innovation and entrepreneurship, and we must continue building the economy side of Israel through high tech, which is responsible for about 40% or 42% of our exports. Just you know, Mellanox today, as part of NVIDIA, is more than $16 billion of annual revenues and growing. And if you've seen NVIDIA report in the last quarter, I think the vast majority of the revenues came from data center. So we're very proud, and I think that this is something I'm very proud about.
You're known as a strong supporter of regional technological cooperation, and perhaps, I mean, in my view, maybe the most optimist person on the planet. Your company Mellanox employed Palestinians from across the region, including from Gaza Strip. And my question is, after the difficult year we've all experienced, and I may add especially you with the loss of your daughter Danielle in the horrible massacre at the Nova party, do you still maintain your optimism?
We need to talk about the two-time. I think, at least from my perspective, I was involved in multiple things to do with the Palestinians, but not only the Palestinians, also other neighboring countries. But after October 7, I think we need to divide this into two time zones. The short period in front of us is going to be very difficult with our relationship. I just came from London, talking with some of our neighbors about what's the next day looks like, and there were representatives of a lot of people there. So in the short term, we need to make sure the Palestinians understand they want to have peace, and them trying to distract Israel is not something that's going to be able to do. Hamas was very successful on October 7, doing a lot of damage. It's also our responsibility, not just Hamas' responsibility, that they were successful. And we need to make sure now that we're strong enough. We need to eliminate Hamas as much as possible, eliminate Islamic Jihad, and make sure we get first all of the hostages back. And there's a lot of things in the short term that we need to do. In the long term, we must be able to live together. And from my perspective, the only way we can live together is two states for two people. I think we need to do normalization with the Saudis as a first step, after we do some steps in the Palestinian side, in Gaza specifically. And after that, we should work with the Saudis as our big partner to fix a lot of things, geopolitical things in our area. And eventually, I believe doing a one-state solution for two people is not a valid alternative. The best thing for us as Israelis is to have a two-state solution. And this is something we're working on to build for the future. It's not going to be easy to do this.
Just one more component to the question. Do you think technology plays a role in overcoming?
Technology plays a role in all aspects of our lives. So defense, definitely. So I think defense is one of the major fundamental blocks in this agreement. So technology plays a role in everything. Technology, we should be superior to all of our neighbors in what we can do, and not just on defense, but also other means, which we lacked in October 7. And we need to use technology for the best to both people, not just to the Israeli side, but also the Palestinian side. And we need to find a synergistic way to use technology for us as Israelis and also for the Palestinians. So technology is definitely a very fundamental building block in part of the, building this environment, building this geopolitical situation between us and the Palestinians.
Including collaboration.
There's a lot of people worried On the Shabak side, Shabak is one of our agencies that's responsible to make sure Israel stays a democracy. Shabak is very much worried about technology on the other side, and we have to take into consideration some of the things, but I believe trying to prevent technology progress on the Palestinian side is, we need to do it in stages. As long as we're superior and we have more capabilities, it's good. But I think we need to collaborate as much as we can. I think for them to progress and to flourish and to be successful is important for us, not just for them.
Okay, switching to another topic, big topic, AI. Where do you think it's heading? What are the opportunities and dangers in the AI revolution? And also, what do you think is the next technological revolution within AI and maybe also beyond AI?
So AI is penetrating into all aspects of our life. It has to do with our financial decisions, with our health decisions, with our driving decisions, with our entertainment. Actually, everything we do, we'll see more AI involved in that. And that's why you see NVIDIA share price continue to go up, which is a good thing. But AI is going into everything, and it's going faster. The acceleration of adoption of AI technology in our lives, in all aspects, is just increasing. And it will continue to increase. If you think of that, today, we cannot even live without the technology. Our lives depend on the technology, on, air traffic, on, hospitals, everything. We really depend on technology more and more and more, and we cannot live if technology fails. So it becomes very mission-critical systems. And one of the things that AI is not there yet, and this is why we don't have yet self-driving cars on the streets, is to be able to count that the mission-critical systems based on AI will be good enough to execute in real time and in real situations. So first, I think we need to develop more hardware to be faster, to enable smarter and more intelligent infrastructure, to enable more things to be integrated. I mean, now we're warm, but imagine like in 5 years, your T-shirts will have your temperature that you want. So you like 21 and you like 27, we sit in the same room. Our clothes will be our air condition, which will also save a lot of money in terms of we don't need to air condition this whole environment.
5 years, you said?
I don't know how many, but yeah, I can say 5 years. I don't have liability. 2 years.
It's recorded.
Even 6 months. But to think of the capabilities that we can do, I don't know if anyone sat in a tank, but in my generation, when you sat in a tank in the summer, you were boiling, and you were really boiling. And today, when you sit in a tank, you actually have air conditioning, you have more, and you can really. So this progress will also made into our clothes, and we'll have individual environment surrounding us that will be better for us. Not only that, if you look at the metaverse, if you look at augmented reality, if you like penguins, if you like unicorns, or you like, they will be with you all the time that you want them to be with you. Your grandfather that's not here for a number of years can play chess with you, because we can make an avatar of anyone that you want that's in the past if we have enough data, and he can read you a book if you want. Everyone that's here on the business trip, you left your kids back home. Imagine that there's an avatar replacing you back home, putting the kids to sleep or telling them what to do and things like this. We can actually have you located in multiple places at the same time, doing multiple functions, and your kids will not miss you as much as you miss you when you travel around the world. So all those capabilities are in front of us. And the more we learn to use the computers to create our reality or our augmented reality in a more entertaining, in a more secure, in a more helping manner, we will gain more. So I think AI is very important. About the danger of AI, everybody's worried about AI. I think AI has some dangers if it goes to the wrong hands. If people put the wrong data, I mean, today when you get a recipe from ChatGPT, you trust the recipe. So if it tells you to put cyanide into your cake, probably you'll put cyanide into your cake because ChatGPT told you to do that. This is a great exaggeration, but we need to make sure that the data we use for learning comes from our reliable sources. So first, we need to make sure that the data is reliable and comes from the right places and not being hacked. Then we need to make sure that people don't change the decisions of the machines according to what they want to change, for example, in elections. The Russians in the US, Iran in Israel, also the Russians here. But so there's a lot of danger in relying too much on AI and not having enough protection to make sure that the data is reliable, the algorithm is reliable, the learning, the inference, and everything. You cannot mingle with it. And that's also now with cyber, which is another very important successful market here in Israel that's growing very, very fast. So I see AI and cyber working together. By the way, cyber itself also relies on AI. So you see a lot of AI tools being used to create cyber security in many aspects. So this is also, we protect AI with cyber based on AI. We need to make sure that's the right thing. And the last thing, today we have AI writing code. So you're from computer science. But if you have AI writing code in the future, we can maybe imagine AI even doing silicon and AI even solving other things for us, physics, doing quantum computing, which we're not yet successful to do quantum computing for more than hundreds of bits, of qubits. I think we'll have AI help us do more and more stuff, accelerate our understanding of what's going on, and I think this is going to be very successful. I guess I'm too long.
No, that's actually just right. The Israeli academia is currently facing academic boycott, just like Tova said before. Has the recent conflict impacted Israel's high-tech image and standing in a similar way? And given these crises and challenges affecting Israel's global standing, do you think that the Israeli industry can contribute supporting research and academia? And the last part of this question is, could you propose a potential model for collaboration or synergy between industry and academia?
A lot of people sometimes don't like me. It doesn't mean that I don't engage with those people. So I engage with them, and eventually we are able to work together. We preach some things, and it's so I don't expect everybody to love me all the time, and it's something we need to get used to. I can understand. I went twice since October 7th to Abu Dhabi. I visited people there, and I have 2 friends there. Those 2 friends are sure that Israeli soldiers are raping Palestinian women in Gaza. Those 2 friends are sure that Israeli soldiers are killing children in Gaza. They think that our officers are destroying buildings in Gaza that is not necessary to destroy, which, by the way, is not true. One of them. When I sit with them, I tell them, look, we have a very ethical army. We may have collateral damage. We can do mistakes. There's a lot of innocent people trying to hurt, but we're trying to not hurt uninvolved people. We're trying not to have innocent or uninvolved people be affected. But there is collateral damage. By the way, percentage of our collateral damage here in Gaza is about 20%, where most of the U.S. operations were around 40% collateral damage. That is, people involved that were killed more than what you want to kill. But you cannot convince them about this thing. When I was in this event, there were multiple events in England, I talked about the hostages. And I talked, I think, for 2.5 minutes that when this is our first priority, we need to release them. No one even winched. I finished talking, everybody went to the next subject without that happening. So I was very frustrated. Why is people not relating to my comments about the hostages? We need to bring them back. We need to work. We need to do everything. And then I thought, only when I went to sleep, they don't care because what they see is the damage we're doing to them. They're in their head, we're killing babies, we're raping women, we're burning their houses and so on. And by the way, in the West Bank, we have an issue with our settlers, which in my eyes are also terrorists, what they're doing there. We should stop that. But in the back of their hand, the hostages is a small problem compared to what they're seeing that we're doing to the Palestinians over there. So once I understood that, I was less frustrated than putting myself in their hand. So
Do you feel that Israel high-tech is affected by this event?
I don't care what I feel. The answer is we should not let this impact any of our results for the high-tech, for the academia. I raised the $56 million in October 11. 1 month after September 11, everybody, no one moved that. We can always have excuses. The way we should continue executing. We should focus on what we need to do. We should not blame, geopolitical events going around us by our failure. And we should just continue executing. Now, when people don't want, in the future, they will talk to us. And those people that today think we're raping women in Gaza, they'll eventually find that this was a wrong assumption. They found it. We are still friends. So I'm very optimistic. I was in London and in Paris last week. I didn't see, by the way, in New York, I was 4 weeks earlier. I saw many more demonstrations on the street and so on. I didn't feel any boycott from them to me. They actually wanted to engage with me. They wanted to talk. They wanted to see how we can find the situations to work on the next day. And if we come with a positive attitude and we don't feel like we're always attacked, and when we are attacked, we should understand why we're attacked, I think we'll become with a better open-minded and be able to engage. I don't think we should take this boycott as something that should prevent us from going anywhere and doing anything. My kids are going now to do, the girlfriend of my son is going to do a master's in one of the universities in London that's going to be like very to the anti-Semitism. But I said, don't let that stop you. Just go there and do whatever you want to do.
Yeah, I have one. I think so. Can you hear me? Yeah. So maybe for the sake of time, one last question. So we are here in Tel Aviv University, a place that educates thousands of students, young people. And my question is, if you could give one piece of advice to your younger self, the age, imagine yourself as a young student, what would it be? What would you do maybe differently?
The advice I should say is just focus on what you want to achieve and go and make this happen. Just execute, just do, and don't let noise or things around you distract you from getting to what you want to get, and just execute what you want to do. And don't have any limitations. Think very openly. Put always yourself in the shoes of the other side and understand what they're thinking. Just execute. I don't know.
So maybe let's take another angle to this question. Something that you thought was very important and crucial when you were young, and now you think it's not that important.
My personal side, I can say a lot. Okay.
You have the stage.
Look, it's a good question because you always come to junctions to choose left and right, and you chose left, and you were successful. So you don't know what would happen if you went right. So I don't know. I think really it's working understanding very, very professional, very professional. This is something to do with the university. You need to understand why the basic courses are there, and it's important. Being very professional at everything you do, understand how electrons and protons work and how to manipulate them, and then build from there up. And after you're professional, you have a better chance of executing and being more successful. Build the right team to work with, and have the right friends to work with, and then just focus on execution. We went through, I'll just give you one example. We went through 3 operations in Gaza and 1 second Lebanon war, where we had already Palestinians working for us. And at the same day, we were killing them, and the same day working with them. And I had no problem with that. And in that time, I worried about our Palestinian Gazan employees and our soldiers there, and I was talking to them on the phone an hour apart. But we need to understand what you're doing, why you're doing. Once you understand and you continue executing, you'll be successful at that. So just focus, be very professional, build the right team, and do what you need to do without taking the noise that's around you or around some other stuff. Understand what your customers really need, put yourself in their hands, build what the customers need, not what you think they need, and just do the right things.
Thank you. Do we have time for a few questions from the audience? One question. Who is the one person?
So the answer is yes. You should focus on what you need to do and do what you focus on. On the other thing, at the same time, I'm trying to replace the government. But this is... we have a significant problem with the current government. If you look at anyone that I met in the past 2 or 3 weeks, and I think Biden, after, by the way, I talked to some of their people, said, came with an announcement, it's very hard for us to work with the Israeli government, with the current government, which was the toughest statement the U.S. president can say, and its implications. So, yes, we need to change the government here, and we're failing until now, but I hope that in the next 4 or 6 months, we'll be able to have some Knesset.
When we have that special shirt.
No, I think it's going to be before. It has to be before. No. If it's there, we're going to be in big trouble. But yeah, so on that, and it's very clear because I say this, and I feel free to say this, because if you look at 95% of the European countries in the US and also Arab countries was with us when the operation started in October 8th. And I think until December, more than 88% of the countries were supporting Israel. Since then, it derated, and today no one really wants to talk to us and support us. That just says a lot about how our government is managing this thing and what we should do, and I think we need to change.
Thank you very much, Eyal.
Thank you very much, Eyal and Michal. And now we'll continue with I promised you that you learn everything about exact sciences, so this is the time. So we'll start with the talk by Professor Saron Rosset from the Raymond and Beverly Sackler School of Mathematical Sciences, and he'll talk about statistics in the age of AI.
Everyone. So I'm Saron Rosset. I'm from the Department of Statistics and Information Research, and I'd like to talk to you a little bit about the place of statistics in the age of AI and big data. So let's start from what is statistics. So like many disciplines in this modern world, what we aim to do is we want to analyze data, we want to build models, and we want to reach conclusions that are relevant and useful, but something that's at the heart of statistics is that any conclusion we reach in statistics should come with some statement of its validity, so or confidence. So this is what we call statistical inference, that we don't just reach conclusions or make predictions, but we try to do everything with some measure of how sure we are or what are the alternatives and so on. And so to do that in statistics, we have various tools at our disposal. And so primarily we use tools for mathematics and probability, but we also try to put an emphasis or try to make use as much as possible of tools of intuition. And there's a lot of emphasis on visualization and visually analyzing data. And of course, computation, which is a staple in the modern world. So the point I want to try to make to you is that also in this age of AI and big data, the sound use of statistical tools actually remains a critical component in this part. And I try to do that through just going quickly through a couple of examples of how statistical thinking comes into this modern world of AI. So the first example I want to talk to you about is what's called conformal prediction. So in general, what AI models do a lot is they try to predict things. And when we say predict, it also means kind of understand what things are. So for example, we have an image, then we might want our AI model to tell us whether it's a cat, a dog, or something else. So as a statistician, I could ask, or we would ask, so how confident is the model in the label it gives? Or can the model also give us alternative labels to the primary label that it gives to that, say, image or whatever object we're applying AI And maybe most important to us as statisticians, can we get something like a collection of labels so that we would have high confidence that the true label is within that collection of labels? So not only get multiple labels, but have some measure of confidence of how sure we are that, or some guarantee that we are confident that the true label is in this. So the model might tell us that this is either a cat or a squirrel, but I'm pretty confident that it's at least, or that it's either one. Okay, then we can think of this really, it's a statistical inference program, beyond just a prediction program. So let's look at an example. So we have some model and we show it some images and we get the top label, the second label, and the third label. So the top one is the model's favorite label for this image, but it's also giving us a second and third alternatives. And we can imagine that we have many images like this, not just 3. And then we can look where, for this set of labels that we gave, where the true label sits for each one of these images. We see that, at least for these few examples, the top label is either first or second. So if we've seen that over sufficiently many examples, we might say that we've learned that reporting the top 2 labels gives us the correct label with high probability, right? So now we have a statistical inference statement about our model. So this is a very simplistic illustrative example of how we do conformal inference. And really, there's been a lot of work in statistics and computer science and machine learning in recent years about various more complex or more advanced ways of doing conformal inferences. There's much more complex approaches with various ways of proving and showing the value of using different approaches for doing conformal inference. So conformal inference is my first example, conformal prediction. The second example, which is closer to what I work on, is related to doing AI on dependent data. So we might have just a collection of data, in this case a collection of images, and it could just look to us like a collection of unrelated images that we may want to do some AI task, some AI modeling task on. But actually, when we look more carefully at this data, we actually see that this is cluster data. So actually, this is the same set of images, and now we notice that it's actually clustered into images of the same person. And so the fact that it's images of the same person means they are somehow dependent, they are somehow correlated. And the key question we may ask ourselves is, how should we account for that when we do AI, when we build models? And we can have more complex dependent structures, like, for example, this data might actually have spatio-temporal data, because these images might be over time, and they might be organized spatially over the world, and people who are closer to each other geographically or ethnically tend to be more similar. So there's all kinds of interesting dependent structures on the data. And this really makes it a classical problem for statisticians, right? So in physics, we have a long tradition, decades of tradition, of modeling data with dependent structure. And what does it mean, modeling data with dependent structure? One aspect is estimating the strength of the dependence. So how meaningful it is that it's images of the same person. If I want to model eye color, it might be very meaningful. If I want to model the location of the nose in the picture, it might not be so meaningful that it's images of the same person. So we estimate the strength of the dependence, the influence of the dependent structure. And why do we do that? Because then when we take it into account, we can build better models by correctly accounting for the dependent structures in our data. I'm not going to give technical details, but this is really a long-standing tradition in statistics, this kind of thing. When we go into modern AI tools, specifically deep learning, but other modern machine learning approaches, it's often less obvious how we should take dependence into account. How can we account for dependence when we apply these models? Like when we have repeated images of the same person, should we take just one example? Should we take all examples and somehow differentiate images of the same person from images of different people, and so on? There's been a lot of effort in my group in recent years on adopting methods. I forgot to mention, so buzzwords or keywords from statistics are linear mixed models and Gaussian process regressions, different way of taking these dependent structures into account. And what we've been working on extensively is how to adapt these tools from statistics into modern methods like deep neural networks, like deep learning. So I'm not going to give any details. I'm just going to give you a quick snapshot of what, like some images that talk about this. So this is just some example of data. This is the prices of rentals on Airbnb in Manhattan. You see an image of Manhattan, and you see the location of the properties that we're trying to model the prices. And you also have color coding because there's different owners or renters. So you have clustering structure of owners and you have spatial structure of locations. On the right, we have some illustration that I'm not going to get into how our methodology works. At the bottom is supposed to be a generic deep learning network. At the top is how we model the dependent structure through a smaller network, and we combine them through a unique loss function that I'm not going to get into. And just at the bottom, it's just an illustration that accounting for dependence substantially improves the performance of deep learning in this. So I'm right on time, and that's.
So we'll take questions at the end, but I want to ask you a question. How many of you understood something? That's a good. How many didn't understand a word? Okay, I think we're doing pretty well in trying, at least. Okay, our next speaker is Batchen Nachmi Aspiran. She's from the Porter School of Environment and Earth Sciences and the School of Social and Policy Studies. And she'll talk about mobility of the future. Yes? All right. So let's talk about mobility of the future. But before, let's see where we are today. So 54% of world's population lives in city, and it is expected to grow to 70% by 2050. The demand for transportation increased dramatically over the last decade, and it will continue to grow, especially the demand for private transportation. In the US alone, on-demand mobility has grown as well and cannibalized mass transit and by 8%. On-demand mobility is an Uber or Grab or this kind of form of mobility. So in cities, housing is expensive and it accounts for more than 40% of disposable income. This is why individuals are moving to the outskirts of the cities. And so the commuting time is increasing. Commuters lose between 45 to 100 hours in congestion per year. And in Israel, the situation is much worse. It accounts for something like 2% of the EU GDP. At the same time, only 50% of urban residents worldwide have convenient access to public transportation. Road traffic injuries are expected to become the 5th leading cause of death by 2030. Transport is the second source of greenhouse gas emissions, and it is the only sector with increasing greenhouse gas emissions. So you understand, global trends indicate a lack of sustainability and inefficiencies of transportation systems. But at the same time, transport is a crucial sector of the economy. It is strongly correlated to the GDP, as you can see. Transport activities account for approximately 50% of the European gross value added and 10% of EU jobs. And any change to the transport sector has strong implication to the society as a whole. This is why countries invest so much in transportation. Note that the investment that China is making as compared to the US, as compared to the other Western countries. So the key question is how to address these challenges without reducing transport activities.
which have you seen already, are key in supporting our lives. So we think that new technologies represent an opportunity to move towards a transport system that is more efficient, safer, less pollutant, and more accessible. And we are witnessing a storm of new technologies and new business models that is transforming everything about how we get around and how we live our lives. The level of the research attention is mainly paid to automated vehicles, mass mobility as a service, drones, what we call air mobility, and e-scooters is just one example that we call micro-mobility. So new technologies result in new mobility options, which will be on-demand, shared, personalized, and decarbonized. The global smart mobility or new mobility size, the market size, is expected to hit around $345 billion in 2032. Most investments have been allocated to new mobility services, as you can see, with more than 2,600 startups funded in the last decade. 600 of them are Israeli. We see also a dramatic growth in new mobility publication from one publication in 1981 to almost 600 publications these days. Key concepts discussed in the literature are the impact of AV on energy consumption and traffic delays mainly, and much less attention is paid to the integration of shared mobility, AV and EV, the integration of new technologies with conventional modes, the expected demand, and many other aspects that have not been yet studied. The commonly used technique to estimate new technology and evaluate new policies come from the exact sciences, as you can see with discrete choice modeling, structured equation modeling, correlation regression, and machine learning tool. But there is a large degree of uncertainty surrounding the short, medium, and long term of new mobility. And optimistic study will tell you that it will reduce cost, vehicle kilometer travel, parking demand, that it will bring reduced energy and greenhouse gas emissions, and it will result in new market shares for disadvantaged group, mainly such as children and elderly and low-income individuals. But others will tell you that it will cannibalize mass transit and even active mode. Active mode are walk and bike. Any energy gain from AV could be offset by the increase in demand, and that these technology may cause congestion. So on their own, they won't spontaneously make our lives better. There is a need to rethink how these transport solutions are designed and operated. And transport systems are extremely complex systems. They are related to every aspect of our life, from poverty to food security, from equal education to economic growth, from gender equity to climate change. So, because of this complexity, we are simplifying many things. We are simplifying urban regions. We are simplifying, we do not explicitly model network congestion. We do not explicitly capture the behavior responses to new technologies. We rarely perform large-scale evaluation, and we certainly do not take into account demand and supply interactions. So, new and innovative analytical tools are needed in order to analyze the impact of new technologies and complementary policy measures in a large and complete urban fabric, along with its complexity. So, such tools I'm developing in my lab. It's called Future Mobility Lab. And these tools are simulation-based tools, and they are built in layers. So we built the behavior. We take a very big sample of the population, and we mimicate the behavior of individuals, each individual in the population, along with its characteristics and household characteristics. On top of that, we built a layer of land use and location choices, Then we build the infrastructure up to the level of the traffic lights sometimes. And then we combine it all together and build the interactions layer between them. And so we are able to perform or evaluate almost any policy in a metro scale, but at the same time look at the behavioral sensitive resolution. We built models and controllers that can communicate with such a system. And so we are able to address the sustainability aspects, social, economic, and environmental. So I'll give you just two very fast examples. What you see here is an output of our simulation. You see different pollution in Tel Aviv metropolitan area as a function of time. At the same time, we can dig in and say why poor neighborhoods have been more affected by pollution than others. We are able to analyze children exposure to PM 2.5 pollution, which is causing health diseases. Another example of our simulation would be this new service that is being operated in nearby Orlando Airport in a place called Lake Nona. This is the beach shuttle bus. It's a fully automated bus running completely by its own. And this bus, we can ask ourselves, what will happen if we, for example, run hundreds of these shuttles bus in Tel Aviv metropolitan area as an on-demand service, for example. We are developing controllers that are able to track each vehicle and to perform ride sharing, EV charging, rebalancing, and choose the energy-efficient routes. But there are many other examples. So let me conclude. We are witnessing nothing less than a revolution in transportation. Technological drivers such as automation, connectivity, low carbon technologies, coupled with new shared trends may redefine how we get around and how we live our lives. New technology alone will not spontaneously make our lives better without upgrading our transport system and policy. It is a unique opportunity to turn the transport sector upside down and make it more efficient and sustainable. Transport systems are extremely complex, and any change in those systems may have negative effect far beyond transport itself and may widen the gaps in our society. Therefore, new and innovative analytical tools may create the right environment in which new mobility solutions are tested together with their supporting policy for a better transportation system and a higher quality of life. Thank you.
Okay, I think the next one is really the test, whether we'll manage to be communicative, because it will be about quantum and physics. So our next speaker was supposed to be Ronnie Yan, but being fashionably late, she got COVID. So we will Moshe Ben Shalom volunteered or was volunteered to replace her, and Professor Moshe Ben Shalom is from the Raymond and Beverly Sackler School of Physics and Astronomy, and he will tell you all the things I don't know.
Thank you, Tova. First of all, I just want to make sure that everybody is in shock like I am, because I think I understood what Mr. Eyal said and then Onen about these avatars, and that actually machine learning is going to take over and everything is solved already. This is quite depressing, I must say. So I don't know. I definitely don't want my kids to hear a story from my avatar when I am, maybe if I'm on the beach. So maybe you can hear me this way. Okay, so I come from, okay, so we have a very bad reputation in the condensed matter department. And basically what we study is materials. Materials must have good reputation. And in particular, we are studying crystals, which are kind of, this
periodic arrangements of atoms. And the way that atoms actually arrange themselves in a material actually set up a playground for the fundamental particles, like electrons. Everybody know what are electrons, I guess. Okay, they're everywhere around us. And basically, the setting, like with people, everything is about the settings. So with crystals, we can kind of imagine the settings, what are the symmetries, etc. And this is going to impact what the electrons are going to do. Okay, so similar to what happens with humans when you put them in a warm room, everybody will fall asleep. If it's after 4 speakers, then definitely everybody fall asleep. But if I was the first speaker and I was sitting here, all of you were awake. So the setting is very important. And with crystal, we can really arrange the settings of electrons in materials. If you look at these atoms, actually, they are very tiny. So in a typical crystals are very, actually everywhere there are crystals. All the metals here are crystals. A diamond is crystal, etc. But if you take a cubic centimeter of a crystal, there is actually about 10 to the power of 23 atoms sitting together there. And the reason they want to go very close together is because then they can share. They can hold hands through the electrons. And when they hold hands, actually, they fall down a little bit. They are lower in energy, and the crystal is stable. And this is really good for us. As I said, the setting is very important. And in particular, when they share this electron, so in condensed matter, sharing is caring. Okay, so everything is about this sharing. And when the electron now belong to many atoms together, they start to act in a collective way. Okay, and they can do crazy stuff, which I think that AI cannot predict. At least I hope. In particular, if we arrange them that they work in a correlated way. Okay, so you can kind of like people, you can put 1 and 1 people together and you get 0. This is usually the case. And in electrons, if you put 1 and 1, you can get 1,000,000. Okay, and there is even quantum weirdness where you can get both 1,000,000 and 0 together, this kind of stuff. And many times we don't, it's very hard actually. So even if I take here, you see here, if I take 100 atoms together, give me the best AI today, no chance it will tell me what will be the outcome, what the electron will do. Because this quantum complexity is actually goes to the power of the number of particles or the degrees of freedom. So it's extremely hard to actually model, understand, and predict what's going to happen, which is good. This is why I have a job. I'm experimentalist. You must actually build the system. But also it's very interesting, okay? And as you heard by the previous speakers, it's extremely practical, okay? Because these crystals here are probably the most common used instrument on Earth these days. And we heard that it's going to be much more than that. So all of this technology, everything we heard, electronics, communication, health, everything has to do with how electrons jump between atoms in these tiny crystals. And each one of us use on a daily basis millions of them. Okay, this is actually more than we use cells in our body. So this is why it's so practical. And quantum is everywhere. I found this picture. There is a quantum company. It's called Quantum Health. It sells a skin cream, which is quantum somehow. I must say, so it's out of my expertise, but I think that there is a buzzword about quantum. Okay, what I want to show you is that quantum materials are the real deal. We use them everywhere, and I think we are going to use them in much more ways, not to create this avatar, but maybe, I don't know, to gain some, maybe we can do room temperature superconductors, for example. This is a dream. AI didn't solve that so far. Maybe we can go with teleportation to the moon or this kind of stuff. We hope that maybe in the future we can do that. Okay, as a physicist, we are going to very simple models. The problem with the materials is that no is different. So you can think about an electron like a small ball. If you know the forces on it, you can, and what happens now, you can say what's going to happen in the future. quantum is also not that bad. Okay, if it becomes a quantum description, actually, if it's a single particle, we just put some waviness, there is some probability, but we can actually say what roughly is going to happen. The problem, as I mentioned, is that when you put them together, they do this crazy stuff. And I give you a couple of examples. So this is an electron. Okay, you see this is a mark of an electron. We call it elementary particle because basically we think, at least in vacuum, we cannot break the particle. It's the most fundamental unit. And if we do experiments in vacuum, we can actually measure the the charge of an electron to very good accuracy. Okay. However, if you now put electrons in this two-dimensional structure atom and you apply some magnetic field, you cool a little bit the system, and you see that the charge, this fundamental unit of the nature, actually becomes fractionalized. Okay, so you can actually make particles which are impossible in vacuum once you put them in a crystal. And actually, the way this is really, really fundamental, extremely cool, because we have kind of only two types of particles. And these kind of particles, they call them anions. They are like anyone. They can do whatever they want, and they're extremely cool. Another example is mass. So, you know, we have, let's say we have an electron in free space. We can measure the mass very well. But if you put electrons on this honeycomb of carbon, which we call graphene, actually, when you try to measure the mass of the electron, you see that it's 0. Okay, this is extremely cool. Usually, if you want to have particles that behave as if they have no mass, we need to use these huge accelerators, okay, and really to push them to huge energies and make them collide. In graphene, actually, which is actually an experiment that you can do in our lab on a tabletop, you can actually make particles that move in a super ultra-relativistic way and see very cool effects, which we are interested in on the fundamental level. But beyond this fundamental level, there are practical and very robust aspects of quantum materials. And this is a very famous Nobel Prize. It's called the quantum Hall effect. So this is actually resistivity or resistance, actually. And this is some other parameter that you change. And you can see that you have here fixed values. Okay, there are fixed values of resistance. It's called the quantum Hall effect. Okay, and usually, you know, this is... okay, let's say that I take this wire, for example. If I ask myself, what is the resistance of this wire? It can be, I don't know, something, 100 ohms. If I do the wire twice as long, what will happen to the resistance? 2 times larger. Okay, if I take this two-layered crystal under the other conditions, you put it million times longer, the resistance doesn't change. It doesn't change up to a 10th digit. Okay, you do this simple experiment and you see really the fundamental values of nature. This is quite remarkable, and so you can use it. You can actually, this is the way we calibrate our instruments these days. This is what we define resistance, and we can use it for very good bits or electronics or whatever. And this is even a crazier idea. So if you remember, sometimes these particles become fractionalized, and our mathematics actually tells us that if you do these fractionalized particles and you kind of braid them in a particular way, then this something that we call phase changes in a way that acts like as if we were doing some quantum computation. And because actually now the information is spread over all the electrons in the system, if you do some local perturbation, nothing will happen. So we call it a topological quantum computation. In a sense, it's supposed to be like an internal error correction that may actually make a quantum computer work. I don't think any quantum computer will, just to make sure that we are on the same page. Okay? Maybe in the future, if we can actually make this would be happen. And one of the challenges that we're trying to do is actually to get this effect also without applying external magnetic fields and at room temperature. And there is a huge progress in recent years. So, for example, we can get this one without any external magnetic fields already today. And the temperature are rising up. So we hope for good stuff. If it doesn't happen, we will ask AI. Okay, and a long history, that was, you know, there was a big recognition of all of these discoveries that we discussed. And sometimes, as Tova, as you said, even the Nobel Prize Committee said that the Nobel Prize goes to another weird thing nobody understands. So we're in good, I think everybody on the same page. But the outcome is clear. Okay, you see these resistance steps? The outcome is robust. There is no question about it. Okay, quantum materials work. And we just need to kind of get used to it. So what we do in our lab, what we basically ask ourselves is, how do we rearrange this playground of atoms? And nature selected few crystals, you know, diamond, I don't know, maybe gold, copper, but we can actually force it to what this is done, doesn't matter. So the very cool part is that we can actually take these individual layers that nature grew, and we can put them as we want, okay? Completely artificial. Nature would not done it by itself for many, many times unless it uses AI. But we do it in the lab, or at least actually these guys do it. And we can actually find some new stuff, and you are welcome to read about it. And thank you for that trophy.
Will not ask who understood everything. Okay, the last talk of today is by Professor Yuval Evenstein from the Raymond and Beverly Sackler School of Chemistry. And he will tell us all about chemistry, right?
I will tell you all about it. But it's all about chemistry. This is why I came with all my props. This is the class. Okay. So what am I? For some reason, just some food coloring and water. Actually, what I came to tell you is that it's all about chemistry. And I really thank all the previous talkers for the kind introduction, all the subcategories of chemistry. It was a good build-up. Now, originally, I thought that this is going to be a hall full of rich people that are going to give me money for chemistry at the end of the talk. As I look around, I realize this is not the case. I know most of you. But nevertheless, I want to convey basically the breadth and depth of chemical sciences, and especially here in Tel Aviv University. So chemistry is positioned very nicely at the interface between the molecular world, the building blocks of nature, and the world that we know here outside. It's the medicines that we take, it's the anti-aging cream that we put on our face, it's the iPhone that we hold and everything that's in it. And even the code inside is many times inspired by chemistry and many other disciplines in chemistry. And I want to give you some examples of the things that we're doing here. So let's start about synthetic chemistry. This is what gave us the white robes. Okay? Synthetic chemistry, where you create new materials from existing natural building blocks. You know, you don't just go to the lab and mix things together and something pops up or blows up. It's rational design. It's based on a lot of computation. We actually apply a lot of AI now in order to bridge all kinds of gaps that we have in our knowledge in creating these new materials. And we have specialized expertise in our school to do all these things. Just one example, for example, I don't know if you know, but check your fingernails. There's a huge problem with fungi in the world. In the last several years, fungi are really taking over. It's vaginal fungi, candida, nail fungi. And one of the reasons is that as opposed to bacteria, where you have a lot of antibiotics, there are only 4 types of molecules against fungi. So in our lab, in our school, Professor Micha Friedman, for example, he specializes in this and he designs molecules that can attack fungi. And indeed, he's done that very, very successfully. But he also added a light-emitting moiety to these drugs so that we can understand exactly where they go and sit inside the fungi. And then we discovered new mechanisms of fungi action that allow to design other molecules that are even more potent but address the same pathway. These are things that chemists do. Yes, now I remember another thing that I wanted to tell you. Okay, sustainability. We heard a lot about what's going on. Yes, it's terrible. And chemists can help. One thing I have here, Professor Moshe Kol, the head of the school, recently invented a polymer from starch that you can make anything out of it. You can 3D print it. But this polymer contains a self-destruction mechanism. Okay? It degrades itself to its basic building blocks and then can be reused again without almost any further processing to print new rubber toys for your kids in the kinder thingy. This is it's an amazing feature because unlike all those Coca-Cola bottles, PET, which have the recycling thing on them, yes, they can recycle, but the amount of oil that you have to burn in order to grind them, melt them, process them to make new bottles, you better make a new bottle. Okay? So it really is about the chemistry, these little tricks that can make a huge difference. Let's talk about energy. So Emmanuel Peled in our school is one of the worldwide pioneers in lithium batteries. He won the Israel Prize for this. Anyone who makes lithium batteries knows him. But, you know, it was in the 70s. No, am I exaggerating? Okay. But based on his work, for example, now Fernando Patolsky in our Department of Physical Chemistry, he's a nanotechnologist. And based on these same principles, he can now print batteries from start to finish on a very thin and flexible layer. I have a prop. Which don't require assembly. Okay. This is battery. This little thin piece of black paper was printed from scratch and then laser printed. It's flexible. This is equivalent to these button batteries that you have in your car remote. And this is all it is, but it's a super battery. They charge and recharge this battery 4,000 times, and it did not degrade. Still stayed 100%. Just now sent for publication. These are things that we do in chemistry with the white robes and everything. Now, on the same principles, another activity surrounding energy is water splitting. So hydrogen is one of the most potent sources of energy in existence. A little spark and it booms away with tons of energy. But how do you make it? I mean, for years and years and years, we realize that water, one of the most abundant resources that we have, is made of an oxygen and two hydrogens. Let's break this apart, and we have loads of free hydrogen. And people indeed are doing this a lot. But what non-specialists don't realize is that in order to do that, they need to take ultra-pure water, which is already a lot of resources to make. In it, they put a very strong base, KOH, almost to saturation, and only then you can stick two electrodes on it, and you will see some bubbling of hydrogen from the electrodes. In the School of Chemistry, we today can take two electrodes, stick them in the ocean, and generate hydrogen. And this is all because of the development of a special catalyst. So the problem with doing this is that the ocean contains chlorine. And once you do electrolysis, as you seep out hydrogen, chlorine ions fill the ocean and kill everyone and everything. And this is why it's not possible. With this special catalyst, you get to a state where the electrochemical energy that you invest first breaks down the oxygen, because it's specific for oxygen, and it leaves the chlorine untouched. But it extends beyond working with your hands and doing experiments. We have a very, very strong bulk of people doing theoretical and computational work. Okay? And I just want to share one example of things that are in directions. The problem of searching for things. I don't know about you, but I spend a lot of time searching. Usually it's my phone. Sometimes it's my keys. But if you think about it, a lot of processes in life involve searching for something. It turns out that if you're searching your keys randomly, you don't know where you left them, you're just going around looking for them. Shlomi Reuveni in our school has proved that there is a concept of restart. It's beneficial and will exceed your chances of finding what you lost if after a while you go back to where you started and you start looking again. People may be already utilizing this for years in their homes, but now we have the formulas to prove it. Now, computers programs, they search for an answer. And so Barak Hirschberg from our department realized that he can use what we know about restarting a search and apply it into a molecular simulation, and this way he can speed up the search for the right answer orders of magnitude, just with this concept. I don't have more time because I can speak for hours, as you know. I want to say one more thing that's important. There are a lot of opportunities in chemistry to make money, okay? And it's not something, I know it's almost not allowed to say it in academia, but I love money. And we generate a lot of talent. We generate a lot of people that are super, super smart and have great tools to go out into the world, and yet they go out into the world and they don't have a job many times. And this is one of the reasons that me and others, we founded the Entrepreneurship Center in Tel Aviv University. And the mission is to give all the students on campus just the language, the tools to integrate not only in the traditional workforce, but also in the Entrepreneurship Center. And this is something that we are trying to drive from the School of Chemistry, and hoping that also the rest of the exact sciences will follow on. And you're not donors, but I don't believe in donations. I'm looking for investors. I'm looking for investors for the School of Chemistry that will help us give our future students the best infrastructure, the best education, the best equipment that we can get. And I'm sure there's going to be a high return on that. So thanks. Bye.